Hello everyone, myself Mirza Dilavia. I am working as an assistant professor in Mechanical Engineering Department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we are going to study about replacement theory. So first of all we will start with introduction to replacement theory. So the replacement theory in operational research is used in decision-making process of replacing a used equipment with a substitute, mostly a new equipment for better usage. Okay, so we will discuss what is basically a replacement theory and why it is required in the industries and day-to-day life. So what is replacement theory? That this chapter will tell us about when to replace a particular machine to give us the better efficiency from the new one. Okay, so consider you are having some type of a machine, and after particular usage of time it will give you less productivity, as well as it will have an increased maintenance cost. Okay, so it is required to replace that machine after some years, and this replacement model or replacement theory will give us the exact idea on when to replace a machine after a particular period of time to get the maximum efficiency as well as reduced maintenance cost. The above discussed situation can be solved mathematically and categorized on the basis like item that deteriorates with time. Okay, so why we will replace machine? Okay, because the item will get deteriorate with time. And which are those items that will deteriorate with time? That is machine tools, vehicles, equipments, buildings, etc. Another one is item become out of date due to the new developments like ordinary weaving looms by automatic, manual accounting by tally. Okay, so another reason why we need to replace a machine, that is they becomes outdated. That is the ordinary weaving looms which is used for making clothes were replaced by the automatic weaving looms. Okay, as well as the manual accounting were replaced by tally. Another reason is item which do not deteriorate but fail completely after certain amount of use, like electronic parts, street lights, etc. That is also known as group replacement. That is the items will not get deteriorate after some time, but they will fail suddenly. Okay, and the best example for it is the tube lights or bulbs at your home. Okay, next is the existing working staff in an organization gradually diminishing due to death, retirement, etc. Okay, so this is known as staff replacement, where we need to replace the staff after some period of time because of their deaths as well as retirements. Okay, next is the type of failures. So basically we will be having two type of failures, that is gradual failure and sudden failure. So first one is your gradual failure. The mechanism under this category is progressive. That is, as the life of an item increases, its efficiency deteriorates, causing, okay, its efficiency will get deteriorate. And what will be the effects of that? That is increased expenditure for operating cost. That is your operating cost, or you can say that your maintenance cost will get increased. Okay, another one is decreased equipment productivity. Your productivity of equipment will also get decreased. And third one is decrease in the value of equipment, that is your resale value, that will also get decreased. Okay, so this is the gradual failure, and you can see from here the examples of those gradual failures, that is your bearings as well as your tires, etc. Second one is sudden failure. This type of failure is applicable to those items that do not deteriorate markedly with service, but which ultimately fails after a period of using. For any particular type of equipment, the period for installation to the failure is not equal but will follow some frequency distribution, which may be progressive, retrogressive, or random in nature. That is, in sudden failure, we do not have an exact amount of time between the installation and failure, but they will fail on suddenly. But they will have a frequency distribution which can be like progressive, retrogressive, or random, and we will discuss all of these. Okay, so first one is your progressive failure. In this mechanism, the probability of failure increases as the life of equipment increases, which is a simple one. That is, as the life of your equipment will get increased, the probability of failure will also get increased. Okay, so next one is retrogressive failures. Some equipment may be prone to failures with high probability in the beginning of their life, and as the time progresses, the probability of failures fall down. That is, some machines are there that is having the high probability of failure at the starting, but as the time progresses, the probability of failures fall down. And why this thing happens? That is, the capability of that equipment to survive in the beginning of the life enhances its probable life. Industrial equipments with this type of distribution of lifespan is exemplified. Okay, next one is your random failures. Under this failure, constant probability of failure is associated with equipment that falls from random cause, such as physical shocks not related to age. Okay, in such case, virtually all equipments fail prior to their expected life. So in this random failures, they do not follow any kind of a particular frequency, and there is a chance that great chance that the equipment will fall short of their lifespan. Okay, some of the examples are given over here. That is the electronic components, delicate or brittle items, perishable items like fruits and vegetables have been shown to fail at a rate independent of their age. Types of replacement problems. Basically, we will study about the three types of replacement problems. First one is your regular replacement, second one is group replacement, and third one is time value of money. We will get to know more about all of these type of problems after we start solving the numericals. Okay, so now we will move to the numerical section. First of all, we will start with the examples related to simple replacement, or we can say regular replacement. Okay. So first example is given over here. A printer costing rupees 6,500 initially has maintenance and resale value as given below. Suggest the optimal time period of replacement. Okay, so over here you are given a question and you are given the data regarding to the years, resale value and maintenance value. It is said that the printer, which has the initial cost of 6,500, it has the maintenance and resale value which is given to you in the table below. Okay, so first of all, now we will make a table. So first of all, this is your given data. Okay, and we will start the solution from here, and we need to make a table first of all, and this table will have 8 columns. In all the regular replacement example, you need to make a table which has 8 columns. Okay, so first column is about your years, which is denoted by small n. Next one is your cost, which is denoted by capital C. Next one is your resale value, which is denoted by capital S. Fourth column will be C minus S, that is your cost minus resale value. Fifth one is your maintenance cost, which is denoted by F of T. Next one is your summation of maintenance cost, or you can say cumulative of your maintenance cost. Next is your total cost, that is C minus S, that is this one, plus cumulative of your maintenance cost, which will be written over here. And the last one is your AAC, which is average annual cost, and that is total cost divided by number of years. Okay, so you will get to understand this more after we will start solving this example. Okay, so first of all, we need to fill the first column. Okay, so in the first column we have to write down the years. So over here in the given data, you are given the years that are 7 years. Okay, so first of all, we will fill the first column, that is 1, 2, 3, 4, 5, 6, 7. Okay, now next is your cost. So what is the cost? That is your initial cost, which is the cost of printer, which is given over here, that is your 6,500. Okay, so we'll write down 6,500, which will remain constant throughout. Okay, so write down 6,500. Now third column is about the resale value, which is also given to you in the given data column. Okay, so from that you need to write down your resale value. That is, for the first year we are having the resale value of 3000. Okay, for the next year we are having the resale value of 2500. For the next year we are having the resale value of 2000, then after 1500, then after 1000, then after 700, and then after 500. Okay, now we will move towards the fourth column, which is your C minus S, that is your cost minus resale value. Okay, so we will fill that column, that is your 6500 minus 3000, which is your 3500. Okay, next is 6500 minus 2500, which is 4000. Okay, 6500 minus 2000, that is your 4500. Next will be your 5000, 5500, 5800, and 6000. Okay, after that next column is of your maintenance cost, which is already given to you in the given data. That is 100, 250, 500, 1000, 1500, 1800, and 2000. Okay, now we will calculate the cumulative of your maintenance cost, that is summation of your maintenance cost. So first year, for the first year it will remain the same, that is 100. For the second year we will add these two, that is 100 plus 250, that is 350. Then after, for the third year we will add for the first 3 years and we will get 850. Then after, for the 4 years we will get 1850. For the 5 years we will get 3350. For the 6th year we will get 5150, and for the 7th year we will get 7150. Okay, so this is your cumulative of all the maintenance cost. Now we will calculate the total cost, and how that is calculated I have already told you. That is, total cost is the summation of C minus S, your this column C minus S, plus cumulative of your maintenance cost. So we will add this 3500 plus 100, that is 3600. Then after 4350. Then after 5350. Then after 6850. Then after 8850. Then after 10,950, and in the last one we will have 13,150. Okay, now we will calculate the average annual cost, from which we will get the idea to when to replace a machine. Okay, so what is the average annual cost? That I've already told you, that is total cost divided by your number of years. Okay, so total cost that will get divided by number of years. So what is your total cost for the first year? That is 3600 divided by 1, so your answer will be 3600. Okay, for the second year 4350, that will get divided by 2, so your answer will be 2175. Okay, for the third year 5350 divided by 3, which will give you 1783. For the fourth year 6850 divided by 4, which will give you 1712.5. For the next year 8850 divided by 5, so your answer will be 1770. Okay, for the sixth year, 10,950 divided by 6, the answer will be 1825. And for the last year, 13,150 will get divided by 7, and your answer will be 1879. Okay, so from this table or from this column of the average annual cost, we will have to write down the answer. And how we will get to know what is your answer or at which year you will replace the machine. Okay, so from this we can observe a particular pattern from the start of the first year, that is from the 3600, that your average annual cost is getting decreased, that is 3600, 2175, 1783, 1712.5. but then after suddenly the average annual cost will start increasing, that is 1712.5 to 1770, and it will keep on increasing. Okay, so from this we can say that we need to replace the machine after the fourth year. Okay, so after 4 years we need to replace the machine. Okay, so your answer will be after 4 years. So after completing this table, you need to write down one more sentence, that is, from the above table we can find out that average annual cost, that is your AAC, increases from the 5th year, so it is advisable to replace the printer after 4 years. Now we will solve another example. A firm is considering replacement of machine whose cost price is rupees 12,200 and scrap value is rupees 200. The running cost found from the experiments are as follows. When should the machine be replaced? Okay, so this is also similar example to the which we solved previously, but over here one difference is there. In the last example, as we can see from here, resale value was given to us for each and every year, but in this example resale value is not given, but instead of that you can see from the question itself that scrap value is given to us. Now what is scrap value? Scrap value means the value of a machine at the end of its life. Okay, so when we will sell the machine at the end of its life, we will get 200 rupees from it. Okay, so this question was also asked in GTU in November 2011. Now we will start solving this example in the similar manner in which we solved the previous example, but only one difference is that we are having a constant scrap value of rupees 200. Okay, so first of all we will fill up the column for years. In the previous example we were having 7 years, now we are having 8 years. Okay, so 1 2 3 4 5 6 7 and 8. Now we will write down the cost. Now what is the cost of this machine? That is already given to you, which is 12,200 rupees. Okay, so which remains constant throughout 8 years. So we will fill up the columns. Okay, now next column is regarded to resale value. Now we are not having resale value with us, but instead of that we are having a scrap value, so we will write down rupees 200, and this scrap value will remain constant throughout the years. Okay, now your next column is what? Which is your cost minus resale value, which is C minus S. So this example will become even more easier than the previous one, because we don't have to subtract the different values, but we have to subtract the same values for the cost and resale value. Okay, so your answer will be 12,000 which also remains constant throughout the 8 years. Now next is maintenance cost f of t, which is already given in the table of the example question. Okay, so we'll write down the data from there, which is 200, 500, 800, 1200, 1800, 2500, 3200 and 4000. Okay, now next column is about the cumulative or summation of the maintenance cost. Okay, so for the first year it will remain same, that is 200. Next is 200 plus 500, so we will get 700. Similarly for the third year we will keep on adding the maintenance value, that is for the third year we will add 200 plus 500 plus 800, so we will get 1500. Okay, similarly we will keep on doing the summation and we will get the answer as follows, which is 2700, 4500, 7000, 10,200 and 14,200. Okay, now we will calculate the total cost. Now what is the formula for calculating the total cost? That we will add the two columns, and which are those two columns? That is C minus S plus cumulative of maintenance cost. Okay, so for the first column we will get the answer of 12,200. Okay, for the next year we will get 12,700. For the next year 13,500. For the next year 14,700. Next is 16,500. Another one is 19,000. Next is 22,200 and the last one is 26,200. Okay, now we will get our answer from the last column, which is your AAC, average annual cost. And how we will calculate the average annual cost? That is by dividing the total cost divided by number of years. Okay, so for the first column we will get the answer of 12,000. Okay, for the next year that is 12,700 divided by 2, so we will get 6,350. Okay, similarly for the third year 13,500 divided by 3 and we will get the answer of 4500. Similarly we will keep on doing this, which is 14,700 divided by 4 and we will get 3675. For the next we will get the answer of 3300. Next one will be 3167. Next answer will be 3171 and the last one will be 3275. Okay, so from here we will observe one pattern, that for particular period of time, for particular years, the average annual cost is keep on decreasing until which year? That is until the 6th year. You can see that from the year 12,000, 6,350, 4,500, 3,675, 3,300 and 3,167. But after that the average annual cost will increase, that is it will increase from 3167 to 3171 and then after it will keep on increasing 3275. So it will be good for us to replace the machine after 6 years. Okay, so our answer for this question will be to replace the machine after 6 years. So after completing this table you have to write down one line, that is from the above table we can find out that the average annual cost increases from the 7th year. So it is advisable to replace the machine after 6 years. Thank you.